good morning, everyone. I'm Dhruv, and I'm very excited to be here. Today, the talk is about building AI and data products. A lot that I'll be sharing is learnings from my own experience, as well as those that I have learned from a lot of peers in the industry. So I think if you are looking to build AI products or data products, I think some of the things that we'll talk about here could be of a lot of interest. The first thing to understand is what role does AI or ML play in the product itself, right? So if we look at the 4 quadrants here, on the x-axis, we've got moving from a standalone black box to an end-to-end solution. And on the y-axis, we've got AI working as a feature compared to AI working at the core of the product itself. So let's look at, for example, quadrant 1, right? This talks about AI being at the core and as an end-to-end solution itself, right? For example, let's talk about self-driving cars or surveillance drones, right? AI is at the very core of it. I mean, we can't imagine a self-driving car without AI, right? That's the basic premise on which it works. At the end of the day, it's also an end-to-end solution, right? It fulfills a user need from end to end. Let's look at quadrant 2. Now, some of these solutions that we've seen, right, many of these are provided as black box APIs, etc. For example, object detection, for example, speech-to-text translation, or for example, a lot of language-related spell checks, etc. All of these fall under the second quadrant, which we call as a standalone black box, which works at a core of a solution. Now, a couple of caveats here if we are in the business of building these solutions. One is, it's important to define the degrees of freedom here, right? None of these solutions, we could say, are generic in nature. For example, we could have a fantastic speech-to-text solution that works well in a typical contact center place, right? There could be a speech-to-text solution that works very well in a clinical place, right? But it's very hard to have something that works well everywhere. Hence, it's very important to have very clear documentation as well as defining the degrees of freedom under which products in this space works, right? So that the expectation settings with the user is done well in advance. Let's talk about quadrant 4, which is products which are end-to-end solutions, but AI is not a core, right? AI works as a feature in the product. Let's talk about many of the OTT platforms that we use, right? They already have a rich repository of content, of videos, of music, of other things, right? But we also got recommendation layers as AI engines, right? So while the product works end-to-end on its own, but AI does help in improving the user experience. AI does help in improving the number of clicks on the average time the user sees, right? But the base product still works. I mean, we could still use a OTT product without a recommendation engine, just that a user experience would be pretty pathetic. When it comes to developing AI products, right, I would like to talk about 2 very important aspects, right? First is on prototyping, and the second is on development. In the typical software world, when we talk about prototyping, right, we generally talk about, hey, wireframes or mockups, etc., right? But let's move to the AI world, right? Let's move to AI APIs or ML APIs that would be used. A typical wireframe or mockup will not be sufficient enough. What we'll also need is 2 more strategies, which are pretty common in the industry, right? First is what they call as humans as AI or Wizard of Oz, and second is what they call as heuristic systems. Now, this becomes also very important because the cost of building such solutions is also pretty high, right? We don't want another product in the graveyard. Hence, it's important to run simple, cost-efficient MVPs. And these are 2 very efficient ways in which it can be done. The typical Wizard of Oz comprises of the software layer at the user interface, but the backend, which is the ML API, could actually be a physical human who's answering queries. It could be, let's say, a chatbot. It could be a machine translation system. It could be, for example, a recommendation system, right? What we really want to understand, hey, is this something really helpful, right? Before we actually invest hundreds and thousands of dollars in building it, right? Such studies were also used a lot in the manufacturing space or in the automation space, where we actually had a human who was working in the backend, but it was the user interface that was getting changed. The second is heuristic systems, right? Whenever we talk about building a statistical system, or we build about building a ML or a DL system, in many cases, a good proportion of it could also be defined by simple rules, right? We don't really have to build models all the time. Let's say 30, 40% of the problem could be solved by simple rules. And that's where heuristic systems come into play. So for example, if you want to run a user study, we don't really have to build the entire backend, right? We can have a simple rules-based system that could mimic some portion of it, conduct user studies basis that, and after that, if that's successful, using the typical A/B tests, then it could be taken up by the data science or AI teams. Coming to the development of such products, right? In such products, when we talk about development, there are multiple teams which are working together collaboratively. There'll be a technical delivery team, there'll be a user experience team, there'll be a customer experience team, or a business team, and there'll be a data science or an AI team. It's typically a good idea to decouple the development that happens from the technical delivery, or let's say the front end or the back end teams, and that's being done by the AI team, right? It's this is one of the areas where having a microservices architecture really, really helps. The reason for that is the development cycles for both the teams might not be in sync all the time. The technical delivery team might also be working on, let's say, support tasks or maintenance tasks or security tasks or changing certain user elements, right? Whereas the AI team might be working on enhancing and improving the accuracy of the models. The other important aspect here is, of course, we all want to be agile. We want to be swifter, faster, fail fast. And there are two very popular ways in which this is achieved in agile, right? One is Kanban, the other is Scrum, right? So Scrum typically refers to time boxing, goals and efforts. And Kanban is a non-time boxed approach, right? Although both of them follow a 3-stage, 4-stage process when it comes from backlog to delivery. But Kanban is generally very, very helpful when it comes to development of ML or statistical systems. The reason largely is about the uncertainty in the data quality, as well as uncertainty in the outcomes, right? So whenever we start a project, it might end in 3 days, it might end in 10 days, or a month, or a 3 month, right? Depending on what the quality of the data is and what the accuracy of the algorithms are, right? And hence, time boxing generally isn't recommended unless we are building incremental enhancements over an existing matured system. Last, not the least, is the role of humans in the loop. Many of these products do, because they are working on machine and human interaction. Hence, the role of humans in the loop is extremely critical, largely for 2 reasons. One, data collection. So many of these systems interact with the users, and the users themselves provide data which is used in enhancing the accuracy of the models, right? For example, all the social media platforms or OTT platforms or a lot of clinical platforms, right? A lot of them rely on the data that is used or the data that is shared by the users themselves. The other is on the data annotation piece, and that becomes very important when we are dealing with unstructured data, right? For example, when we are talking about NLP solutions, or when we are talking about audio AI solutions, or when we are talking about image processing, or when we are talking about object detection, right? A very, very large chunk of the work does require data annotation as well. Hence, when we talk about data collection, these 2 strategies are very, very integral even before we start building the product. As I just mentioned, there are about 3 to 4 sets of people or groups which are very, very relevant when it comes to building AI products. In a typical software product, for example, people in the data science domain might not be very relevant, but here the teams from the data science or the data science anchors or citizen technologists, they start getting very, very relevant. I think we are all aware of why product managers or product owners are important, why a user experience designer or a UI designer is important, and of course, the technical delivery folks. We spoke a lot about AI products, why they are important, how they are important, and some of the useful tips and tricks in building such products. Let's talk about data products, right? And in the last few years, data products or data as a product has become very, very, has been trending in the industry a lot. Typically, when it came to data, they were generally viewed in a services model. Hey, I want this data, I want that dashboard, fetch me that, right? But when we talk about products, we are talking a lot about standardization, right? We are talking about building something that could work at scale, right? And that's where the data community is also getting inspired a lot by the software community. Let's talk about some of these elements here, right? When we talk about data being used as a product, there are generally two dimensions or two levels in which it is done, right? One is what we call as data products, in which typically, we are talking about sharing raw data or sharing derived data, right? For example, let's say we are working in an organization and we are the data analytics or the engineering group, and you got multiple stakeholders who might be requesting for data, right? Marketing team, finance team, sales team, IT team, so on and so forth, right? And they would be requesting for a lot of raw data and derived data, sometimes at an ad hoc basis or sometimes at a batch, monthly, fortnightly basis. If we expand a bit, we talk about data as a product, right? And all the levels of data products start coming into place. We all have heard of the typical cycles of, hey, raw data, derived data, algorithms, moving to decision support, moving to automated decision making, right? And this is something that's trending in the industry a lot these days. People are talking about data meshes, for example, right? And that enable data being used as a product at scale, right? So they are essentially talking about data non-decentralization, right? Or domain-driven data ownership. So they are saying, hey, we don't really have to build a data warehouse all the time, right? Each and every function or each and every unit in the organization could be the owner of a data product themselves. For example, the marketing teams can be the owner of a data product, and everybody else in the organization are their clients. Or, for example, the finance team could be the owner of a data product, right? And everybody else in the organization could be their client. Of course, it sounds great in theory, but yes, there are challenges. For example, data governance becomes a problem. When data is centralized, we have standard set of processes which are utilized in data governance. But when we talk about decentralization, right, or domain-driven ownership, it will be very, very integral for each of these domains to be fairly mature in the way they do data governance. When it comes to data interactions or how user interacts with the data, it's generally in three ways, right? Web elements, let's say certain widgets that we see in a lot of products and websites, the oldest and the most popular way. Dashboards and visualization, I think we are all aware of this, and I'm sure every organization today has dashboards, analytics, multiple layers, and reporting. The third is APIs, right? And this is something that's getting very popular these days as well, right? Where data is not provided to you in the form of a dashboard or a report or a web element, but it is provided through an API, right? Just like ML APIs or software APIs. We spoke about this some time back, but data is what makes AI products hard to make, right? I think we are pretty mature when it comes to building software products which require business outcomes or which require user needs. They also require technical delivery and a strong element of user experience, building mockups, wireframes, conducting A/B tests, doing a lot of creative testing on how we could get the most bang on the buck on the product that we are building. However, having the right data strategy when it comes to building AI product becomes extremely, extremely critical. And we have a whole dozen of data architectures available today, from data warehouses, lakes, lake houses, fabrics, meshes, and so on. But getting this right is very, very integral, and I think this is one place where I think we are all trying to be better than where we were yesterday. Why are we even talking about AI products and what makes them very special, right? If we talk about a typical product, a typical tech software product, it has a maturity cycle, right? It's typically introduced in the market. There's a growth phase, there is a maturity phase, and eventually there is a declining phase. It could be because of losing relevance in the market. It could be because of competitive intensity. But this is how typically the growth and the trough cycle of tech products work. When it comes to AI tech products, there's a flywheel effect which excites everybody, right? And what the flywheel effect implies is, you build a product, you get some users, you get more data from the users as a part of your data collection strategy. The algorithms get better because they are now getting more data. Hence, the product gets better. There are better recommendations. There are more users who are coming on the platform. There is more crowding effect that happens on the platform. And these end up getting more users, right? And that's what makes many of the very popular tech products today have a very, very strong moat, right? Because they have so many users, and that helps them be a lot ahead compared to the competition. We spoke about data, right? And while data as a strategy is very, very important, collecting data in the products also is very, very crucial, right? And collecting it in the right way from multiple sources is also very, very integral. If you talk about the data strategy itself for a product, or let's say even for an organization, there are two kinds of data sets generally, right? And that's what product managers need to think about all the time. There is data that's required to run the business or to run the product. And then there is data which is required to grow the product, right? And these could be very, very different. There, of course, could be a lot of overlap, but the data required to grow the product might require more innovative thinking, right? People are even talking about, hey, I need a separate team for exploring external vendors. I need an external team for exploring external data sets, right? The data which I have is not enough. This is not going to give me consistent edge over my competitors in the long run. It's also very important to conduct a typical 100-year-old SWOT analysis on the data. What are the strengths, weaknesses, opportunities, and threat, right? And it might be a nice 4 to 5 hour design thinking conversation among some of the leaders on, hey, I am building something which a lot of my competitors are also building, and the edge that I have is the richness of the data. The algorithms are the same, the tech platform is the same. The user experience might be a little different here and there, but data is where my edge is. And hence, it might be very, very helpful to conduct a SWOT analysis on the data set. Coming to data collection methods for enhancing either the data product or data as a product, as well as AI products, these strategies are very popular, right? And each one of them has its own pros and they have its own cons. While we would like to have as much data as possible because we are all data hungry, we want more and more data, but it's important to understand that collecting data also has a cost associated with it. Not just money, dollars, but also time and effort. So it's useful to have the right strategy to invest the right amount of time and effort on collecting the right sets of data. The first is leveraging open data. Second is crowdsourcing labeled data, which is very popular, especially in the unstructured data world. For building new features, collecting data from the users themselves, which act like a feedback loop or an active learning loop in many of the products. Having proprietary company data gives a very, very strong edge, especially in organizations which have been in existence for a long time. I think they are sitting on repository of rich data last 20, 30, 40, 50 years, right? And that gives them a lot of edge compared to the newbies in the industry. And purchasing data, of course. I mean, there are quite a few organizations, startups, vendors out there who have data sets collected and purchased, and they're ready to share them with companies or product groups at a cost. Another important aspect is about minimum viable data. Whenever we build a product, we always talk about, hey, let's launch the MVP, figure out, do users like it, do users not like it, what are they saying about it, what improvement can I make on it? At the same time, it's also very important to understand the minimum viable data, right? We'll talk to any data scientist and the person would say, hey, I got 70 fields, I need 40 more, right? The hunt for data never stops. But hey, we got to draw a line somewhere to begin development, right? We can't keep hunting for data all the time. And that's where having the concept of minimum viable data becomes very, very important, right? Why is it important? Of course, we have to draw a line somewhere. The other important thing is we have to manage costs as well, right? Smaller data is also easier to analyze. The more data we have, the more time it takes for us to analyze. Hence, having the right fields and the relevant fields becomes important. And that's the reason why the more data we have, the better it is, but it always comes at a cost. Hence, for doing MVPs, having an MVD equivalent for building the model is also very, very useful. Here are some of the pros and cons of the different data collection strategies. We talk about open data. Yes, it's freely available, or it might come at a negligible cost, but then it's generic in nature, right? It's very hard to get open data which would serve a very, very, very specific need. Crowdsourcing labeled data, this is a strategy which many of the large tech organizations are using today. There are organizations who are also acquiring certain companies which specialize in data annotation, especially when it comes to unstructured data strategies, let's say for object detection or image labeling or audio annotation and things like that. Collecting data from the users always has been a very useful strategy. All the social media platforms use it very, very extensively. In fact, this is one of the very, very, very key element of the entire product itself, which is active learning or enhancing the model very, very frequently basis what the users are doing and the users are saying on the platform. Company-owned data, as we said, again, is something that gives a lot of competitive edge. The advantages, of course, it's readily available, it's within the organization, and it's very, very, very contextual to the problem the organization is looking to solve. The cons, of course, is it might not be very well organized. The data might be very, very siloed across the various islands in the organization, and it might not be sufficient. It might not be expansive. It might not be covering all the use cases that the company is looking to solve. Okay, I think with that, I'll sort of close the conversation and my talk for now. But I hope this was helpful, this was useful, and any questions or any suggestions, more than happy to answer.